Hi everyone and welcome to this tutorial. I'm Marco and today we're gonna have a look at this growing plant animation. We will go through the modeling part, the animation, the shading and then the rendering. Keep in mind I'm not a Houdini expert, so there are surely some better and faster ways to achieve the same result, but this is my workflow, so if you have any suggestions or if you see some mistakes, please leave them in the comments below. Before we get started, I want to thank Rich Nosworthy for this amazing course where you can learn how to create an intricate and detailed flower setup. He covers the modeling part, the animation, the geometry instancing, Vex programming, proxies, and stuff like that. There are also some important topics like the quaternions and matrices, so I suggest you to have a look. That said, I want to say sorry for my bad English. I'm probably gonna make some mistakes during the course, so sorry for that. Let's get started. Here we have our Boston fern reference photo. This is a plant I have in my kitchen. Here you can see the shape of the leaves, the curvature of the stem, the stalk here. The V shape of these leaves. You can see they are very wavy in their shape. The leaves are smaller at the tip and at the root, and they are larger here in the middle part. Here is my workflow. You can see we have a part here for the leaf creation, modeling and animation. Then we have a part here for the stem. And then here we're going to apply and merge together the two things, the leaves on the stem. Let's get started. From here we have a line. As you can see, we model in the Z direction because it's the best way then to apply instances on other objects. I will go through all the nodes and you can follow me watching the parameters and the values here if you want to recreate the exact same thing. So let's get started. We have a line, a 7 points line. I just edited it a bit to create this kind of shape. Then I resample it using a maximum segments of 10. Then I just edited a bit using an add node and connecting the first and the last point, so we can close the shape. Then I sweep it. In this way you can create polygons. I just subdivided a bit with a depth of 1, and then I mirrored on the other axis like that. Then I fused it because we had a couple of overlapping points. Then I edited just a bit because, as you can see in the reference photos, these leaves have got this kind of a bulge here, so I just try to recreate it. Then I subdivided. Let me deactivate these points. Okay, I subdivided, and this subdivision is linked to this quality null I created. And you know how to create this kind of custom controllers. You just create a null, then you go here, edit parameter interface, and here you have all these custom values you can create. So you have vectors, integers, floating numbers, sliders and stuff like that. And I created this quality null linked to this subdivide. So I copied this parameter here, copied, pasted here, so I can use this null wherever I am in the workflow to control the quality of the leaf, like that. Let's move on. Then create a group edge, just applying a group node, deactivating the base group and activating include by edges and taking these unshared edges. So you can see we have just the border. Then I subtracted using a bounding box the first part. We're going to see the reason for this later on. And I promoted the group from an edge group to a point group. And in the end, I applied a group range to select one every 3 points here. In this way, I've just selected some points to be used for this kind of saw effect. Let me deactivate the points. Okay, for this saw effect. And as you can see, it's a bit animated. between first frame and 125. So like that. Why am I animating this? Because I had some problems later on with the banding effect, so try to keep things in their original position to avoid some glitches. Then I applied a smooth, just to smooth a bit the edge, some edges. And then I recreated this group, this edge group here, just by subtracting from the existing. Then I jittered the points just on the edge. I just moved them a bit, as you can see. Then I fused them again because here we had some glitches. Then I applied the normals. Maybe this is useless, but who knows. And then I created a primitive group called leaf. In the meantime, I have this line, which is the, I call it is like a stalk inside the leaf, this part here. So I created a line. This is 5-point line. I resampled it using maximum segments of 50. Then I sweep it using a round tube and a scale ramp from 1 to 0 here. Then I applied the normals, then I applied a primitive group called the branch. It's not the right name, it should be stalk, but never mind. Then I used this simple transform node just to move a bit in the y direction, in the positive y direction. And then we merged together these two things. Okay. Then we have a group delete. We delete these edge groups I created earlier. And then I created this mask. Why am I creating this mask? Let me show you the mask. Okay. I created the mask in the Z direction. So we have a value of 0 here, where you can see the black color, and the value of 1 where the red is full. I'm going to use this mask later on for some effects. Just to clarify here, it's an attribute wrangle where I created a floating mask using the PZ value. I then applied a UV project using this photo I have of a leaf of the plant, just to understand what's going on here. Then we move on to the noise attribute VOP. You can dive in, and here you manipulate point position, noises, colors, all the stuff that regarding points. So as you can see, we have an input here and an output here. We just take the position of the points and we fed into this add node, and to this add node we created this attribute noise and this anti-aliased noise. Remember to tick here the 3D noise, otherwise you get some strange results. And then I just promote all these parameters. A fast way to promote them is using, let me apply another node. You just go here in the Vex VOP options and you create input parameters like that. Let me show you what happens when we add this displays to the original point. I animated this, so as you can see, all the leaf points are moving, but I don't want this effect because I want this part to be sticky. So I multiplied this anti-alias noise to the mask I created earlier. Do you remember? We have a 0 value here in this part, in this region of the leaf, and a value of 1 in this part. So if we multiply this and we then add this to the original point, we get this result. Okay, so this part is sticky, and here we have the full movement. And the promoted parameters we had, I just animate the offset values. Don't get scared about this string here. We're going to have a look at this later. Just focus on this one. It's the most simple one. It's time divided by 2, so it's half the speed of this offset in position in the z-axis. Let's move on. Look, this is the long band. Let me activate pressing G and activating this one. G, okay. You can see if you click G, you can have the full controls of the banding node. And I just animated this band and this capture origin with these values between the first frame and 100 frames. This one a bit later with these values if you want to use them. It's very straightforward. Then I use this smooth to try to I don't know, this is a point maybe I'm asking you if you have suggestions, please leave them in the comments below, because as you can see this banding is very sharp here. I tried to recreate more of a smooth fall off, but I didn't solve the problem with a smooth. So if you have other suggestions, please let me know. Then let's move on. At this moment we have this banding, but as you can see the leaf is very unrealistic because it's flat. But as you can see here, we have kind of this V shape. Oops, sorry. So we apply a new attribute VOP. We go inside, and here it's a bit more complex, but don't worry, it's very easy. The idea is to display some points to create this V shape, okay? And the idea is this: I just took this the point values, which is, as you know, is a vector. I converted them using a vector to float. Okay, so we have x, y, and z. The x and the z values and the z values, I just fed them to this float vector, so they remain the same, and then I just plug the vector to the output position. The values that I'm playing with are the ones stored in the y-axis. So I just take the y output here, then I fed them in the add, and we just had this parameter, which is just a number. We can't see here because it's here, okay? It's a value of 0.3. I just had them, but as you can see, all the points move 0.3 from their original position. So we have to control a bit more this one. Let me deactivate this. I used a multiplication, so I took the x-axis values and multiplied them by this 0.3. The x value here is 0, and the more we move from this position, the more the value increases. So we have this kind of slope here, which is good, which is what we want. But here we have a strange result, because here we have negative values. In this way, if we just plug an absolute node, all the negative values change their sign into positive. So we have positive and positive here. Okay, so let's move on. As you can see here, it's this 0.3. It's animated for the same reason of the glitches I had later on. So it starts from 0 and then it moves to 0.3. Okay, then we have this lateral band, because the V shape is a bit unrealistic. So I tried to bend it just a bit using these values. Also, this is animated from 65 to 28. And remember to take here the form in both directions. So let's move on. Band, this is a general band. I applied this effect because, as you can see here, okay, it's a bit better now, the shape and the movement of the leaf, but it's very straight. So I applied another band. This is a general band which starts from 10. I only animated this one from 10, then it moves down to -25, and then it goes up to -5. We have this trail and this transverse V. This is a failure in this my workflow. I tried to transfer the velocity of these points, of the movement of these points, for a motion blur, but I failed this because we have a problem here using the smooth and fuse nodes. When the shape is here, the points are slowly increasing, so we don't have a consistent number of points, and in this way we cannot have the motion blur. So not a big deal, because we can just apply a motion blur in post-production. In this case it's not very important. But if you have some solutions for this inconsistent points here, let me know. So don't look at this nor this. Okay, let me deactivate them. Let's poly extrude. So we had a very flat surface, so we extrude it just a bit here, and remember to take here the output back, otherwise the back is not created. And remember to take also this side group, which is going to create a group only here on the side polygons. Smooth it just a bit, fuse it for the same reasons we had before. Then I beveled a bit just to obtain a bit of reflections here. And I use the extrude side group, which I created here earlier, this one. So it's going to extrude only here. And remember about this exclusion tab here, which is hide. If you don't tick it, it's going to create a lot of useless bevels, and I don't want that. So I just put an angle near to the 90, less than 90 obviously. And this is the value of this bevel. Then I applied this, I applied this general scale, which is just a scale from 0.2 to 1 to the entire leaf. Then I moved, as you can see here, I moved the leaf just a bit, because you have to keep in mind here we have the stem. So I moved it a bit, I reapplied some normals just in case, and here we have our leaf. Alright, so let's move on to this new part where we are going to create this animating stem. As you can see, it's very low in resolution, but we just needed to instance leaves on it. So let's get started. We have a curve here. It's just a 4-point curve. Just edit it a bit in the Y direction, nothing special. Then I apply the resample with 180 segments, and this is very important, we apply this curve view attribute. We're going to use it in a bit. To explain it, I just use, well, let me create a new line so I can show you better here. Okay, resampled it. Resampled maybe with 20 points. If we apply this curve view attribute and we show here, we create this kind of a gradient. Okay, this attribute is very important because it's a gradient between the first point, which is 0, which has a value of 0, and the last point, which has a value of 1, and we have a gradient of floating numbers in between. So if we increase the number of points, we create this in-between steps. Let's go here to the resample page, and here in the curve view attribute you can see that creates a point attribute storing the unit curve parameter value for the resample point. This attribute is very useful because you can apply, as you can imagine, you can apply some masks in some points, in some parts. You can play with something happening along the path and stuff like that. You can create a lot of effects, and this is very important. Obviously, the curve view attribute, you can only apply it on a line or on a curve. So let's get back here. We've created this curve view attribute here. As you can see, it's impossible to read because there are a lot of numbers, so we deactivate visualization and we move on. At this point, I just put down an attribute wrangle saying that the normals are in the positive x direction, so like this. Okay. Why are we doing this? Well, we're gonna see in a couple of minutes. So the first thing is this. We put down a skeleton node, then you have to click stash input, and it's like, I don't know, cache the actual position, scale and rotation of the points, the previous points. So every time you're going to edit these nodes, the previous nodes, you have to restash the input. And after that, if we have a look at these attributes, you can see we have this specific attribute called local transform, which is a 16 float matrix. All right, so if I go to the spreadsheet, as you can see, for every point, we have this 16 float attribute, which is a matrix. What are matrices? Matrices are a different way of representing and storing translation, orientation, and scaling values for a point, for an object, etc. And it's like a 4x4 grid, so that's why we call it 4x4 matrices. Otherwise, it could be 3x3. Okay, and here you can see it better. The combination of these points, which they appear nonsense at this moment, but if you combine them, you obtain your translation, orientation, and scale. For example, these numbers are for translation, these in diagonal are for scaling, and these ones are for orientation, linked all together. Let me show you with this pig head, for example. When you want to transform it, you put down a simple transform node, for example, like this. Now we can output this attribute, an xform, and as you can see, the xform is a 16 float attribute. Keep in mind this is a detail attribute, so if we want to move an object on the exact same position using an attribute, we can just do this, for example, and we type matrix m equals to detail, because we're dealing with detail. The second input, which is number 1, the xform attribute, and 0 for the prim number. Okay, and now we can just multiply this position by the m, by the matrix, and here is the result. It's gone in the same position using this attribute. Okay, and I can show you this by clicking here the xform. Okay, as you can see here we have our 16 float attribute xform. Now, what's the purpose of this local transform? Well, the matrix, in this case, using that local transform attribute, gives us the chance to control every point based on the adjacent points. Okay, so we can use this local transform to move or rotate the points based on the relatives one. So as you can imagine, now we can have a point rotating, then the second one is rotating based on the first one, the third is based on the second one, and so on. Now we are going to rotate these points based on the adjacent points to create that unrolling effect. And as you can see here, we have a rig attribute wrangle. It's not a common point wrangle, it's a rig attribute wrangle because it's linked to this skeleton. I created this code inspired by Rich Nosworthy's course to create this unroll effect. We're going to create it from scratch, so it's more easy to understand since this is a bit difficult topic. Okay, so let me activate this. We just need this, rotate. Okay, if I click F1, we can see here we need this applies a rotation to the given matrix, and we need a matrix, an amount, and an axis. Okay, expressed in vector. We have that local transform attribute we just created, which is a 16 float attribute. So we type for local transform. Okay, then we need an angle, then we need an axis. As you can see here, we already have an axis, which is our n. we need an angle. So let's create a variable, a float variable called angle, and we can create a channel slider, a floating channel slider. We can call it angle. It's not a problem. We can move the slider, and as you can see, every point is rotating based on the previous one and the next one, okay, based on the relatives. But this is not what we want, because this is a strange effect, so we need to create something that drives our rotation to happen. So, first thing first, since we are dealing with degrees, we need to convert that in radians, because Houdini is working with radians. Okay. And maybe I can increase here the range from minus to positive 180. This is the same effect. And I don't want to animate this one. I want to stay, for example, here, minus 60, 71, and drive which point is going to rotate and when. And to do so, we need a new attribute which controls this from the start till the end. As you remember, here in the resample, we've created this curve view attribute, so we can use it. Let me type float, create this attribute, we can call it mask if you want, which is called to the curve view attribute. Okay. To better understand this, I'm going also to create an attribute from the variable. Okay, here we have an attribute based on the variable we just created, so we can see better what's happening in the geometry spreadsheet here. As you can see, we're starting from point 0 with a value of 0, and we're going to point to the last point which has a value of 1. Now we need this, we need to apply the angle, we need to multiply the angle to this new mask, so we can unroll step by step this stem. So what if we just offset these points? Maybe we can add something to this mask and we call it offset. Okay, let me create this offset slider, and as you can see now we are offsetting. So if I type this 1, I just add 1 to the first point, and the last point becomes 2. If we had -1, we go from -1 to 0. Let me show you also here in geometry spreadsheet, -1 to 0. But if I clamp them, let's say we clamp the mask values between 0 and 1, all the values above 1 and below 0 are clamped to 1 and 0. So as you can see now, we have obtained this effect. Let me just change these numbers, change the range between -1 and 1. Okay. Where the values are 0, there's going to be no rotation. And when the values are 1, the rotation is fully applied. So at this time, it's very simple to understand what we're going to do. We can delete this, we don't need it anymore. We can just multiply the angle by the mask. And voila. Let's create an angle, maybe -71. And here, if we move the slider, we have the perfect effect. So we are slowly bringing all the values to a 0 rotation. Okay, starting from a fully rotation here. To conclude this, we just need to animate this offset, so we can go back to our original setup. I animated this value, this offset value, from this number to this number, -1 at 175 frames. Then let's move on. Attribute delete. We don't need all these attributes we have here. We have a lot of attributes, we don't need them. Also the local transform is not useful anymore, so we delete everything except for the curve view. Okay, so at this moment we have this kind of effect. We lost also the normal, and with this orientation along curve we're going to create the normal again. And the normal is based on tangent, as you can see here. All the normals are tangent. The new n is represented by this tangent, and the up vector is the x-axis. Then we have this noise, which is animated using these formulas. I think I just played around until I found the perfect values here. And as you can see, we are taking the points. We're using the same concept we've used before. So we take the points, position, it's a vector. We add to this position this anti-alias noise. As you can see, everything is moving. I don't want this. As you know, we already have this attribute. It's called a curve view. I just multiply this curve view here with this one. So in this case, as you can see, we have a fully noisy pattern there, but here at the beginning it's 0. I just ramped a bit. Let me see here. Yes, I ramped it a bit and added here this curve. But I don't want the noise to happen in every axis. I just want in the x and y axis. So I applied this, I unticked this, and voila. Let's go to the next one. This is a band. We already have seen this. It's a band. No, sorry, this is a twist. It's a twist, as you can see here, with and without. Without is very straight. With a bit of twist, we create some more organic and natural shape. Okay. It's like a lasso, something like that. Then we move on to this transform. This transform is just a rotation. It's a rotation of the entire stem. So you can, if you want, you can just try and put your numbers there if you want to achieve a more organic rotation and movement to this one. Okay, sorry, I just cleaned a bit this part, and I moved this orientation along curve from this position here down. So let's take the first route, which is this, which led us here to the low poly stem, this one, and we need these points to instance and create all the leaves. We start with a resample node, using a maximum segments of 40, which is the number of leaves we want. Then we put down a group range node with a selection 1 every 2, using here, and call the name selection. Then we want to flip our up vector and the normal vector we created here in the orientation along curve. We cannot invert here because we need these values later on, so we just come here on the flip, on this flip node, which is an attribute wrangle called flip, to flip the axis, as you can see now. All right, what did I do? I just created a variable called up, storing the normalized n vector. Then I say that n equals to the up vector, and up vector equals to the app variable. So we just flip it, very simple. Then we need to alternate these directions as we said before, because one leaf needs to go in this direction, the other one needs to go in this direction. So we just create a matrix. Let me show you what we did here. Whoops. Okay, so we start from here, okay, using a rotate, and we apply this only to the selection. Okay, so half the points are going to rotate in the other direction. So let's start with the rotate function, which applies a rotation to the given matrix. We now know how this works. We need a matrix. We don't have a matrix at the moment, so we create a variable storing an ident function, which is a function that returns an identity matrix. An identity matrix is just a matrix with default values, okay? It's like putting down a transfer node after an object without modifying the values of the transfer node, okay? The default values. Then we need an angle, and we create an angle here with float angle. And remember to store this in radians. We create a slider with the angle we want, like this, so we can decide how much to rotate. And we give a bit of a random number. The random number is just a fit function using the random of every point between 0 and 15, okay? And so you can see here there's a bit of variation. And here we don't have it at the moment because we are just working with the selection group. And then at the end, we just multiply the n by the matrix. Here I just negate the direction of the up vector for the non-selection group, okay? As you can see here, okay? This is before, this is after. We need it for the leaves orientation. Then here we have another matrix wrangle. It's the same as here, but it's working on the non-selection group, okay? And he has got different values here with the fit. As you can see, if I modify the values here the randomness is more pronounced. So let's go back to the other values, okay? And without this rotate, here you can see the effect. As you can see, it's not what we want because we need a sort of a V shape. Okay, let's move on to the p-scale. Remember that all these nodes, you don't need to retype these again. You just go here and you save as a preset, as I did here. And you can reuse it every time you want. So let's move to this p-scale attribute. I'm working with a fit function. As you know, the fit function needs one value, the minimum and the maximum. So the minimum is this slider here, the maximum is this slider here, and the value is just a random point number, okay? Everything is multiplied by this scale ramp, which is a variable I created here, which is a ramp that uses our curveView attribute. Do you remember it? So here is a value of 0, here is a value of 1. We can use it and remap it in this channel ramp here with this curve, okay? So we start with the scale at here at, I don't know, halfway. The scale of the points are going down, okay? So now let's move to this time offset. Just remember that our leaves are going to grow one after the other. And so I created this offset that we're going to use it later, which is an attribute called toff. A time offset, it's a negative value, it's a negative float, using our curveView attribute multiplied by this slider here. Okay, now let's move on to this wrangle node, because I need to rotate a bit these normals. As you can see, they are perpendicular to the stem, and I don't want that. You can watch the reference photos. They are just a bit rotated upwards, okay? And to do so, we can use the original normals direction, which is tangent to the line, to the curve, okay? And create a bias so we can move from this position to this position at the desired angle, okay? To do so, we just create a transition using a lerp. A lerp is a linear interpolation between two values, okay? We need the first value, the second value, and an amount. It's like a bias in a mixed node, okay? So as a first value, I put down my normal. As a second one, I put down my old n, which is stored from this one. And how I do this? Well, I connect this to the second input, okay, which is number 1, and I just call it using this variable called old n, op input number 1, which attribute? The n attribute. Okay, so we have the first value, the second value. Now I need a bias, so I create a slider here, and as you can see, if I move the slider, I can go up to 1, which is the old normal position, to 0, which is the one that I have now, and if I go here 0.167, it's a bit rotated. Alright, so let's move on. Here I have a p-scale correction wrangle, but I think it's not necessary for you. It's because later on when I tried to shade and animate and start rendering, I discovered that some leaves were intersecting with each other, so I tried to scale the ones that gives me some errors. But I think it's not necessary in every setup. So now we are at the last part where we connect the leaves onto the stem. Alright? And to do so, we just need to copy the geometry, which I call here with a lumped object merge, and is pointing to this out leaf. Okay, we created earlier. I copied this geometry to these target points on the stem, and this is the result. Okay, but as you may expect, this is not what we want, because as you can see, the leaves are appearing at the same time, and they have the same noise offset on them, so they appear the same. Okay, and we need to diversify this thing and create this gradient for their appearing. So how to do this? Well, we need to put this copy to point inside a for each loop. Okay, so for every loop inside a for each loop, we get a different iteration, and every iteration is going to have a different noise or a different time for appearing. Okay, it's a bit tricky and a bit difficult, this part, but I hope I can explain it well enough. So we create a for each loop. Okay, when we create for each loop, you just have this. Okay, so you need to create the meta import. All right, and this node is very important because it stores a detail attribute we need, which is the iteration, and it's the number of iteration for every loop inside for each loop. Okay, so we feed this leaf inside the loop, and the loop is going on for 40 times. Okay, and so in this way we can take the iteration number, put it somewhere in a parameter, for example, so that every loop has got a different value on that parameter. Let me show you an example. Here we have our noise. If we can remember, we have this noise for the leaf. If we feed this leaf inside a copy to points, the noise is going to be the same, okay, for every leaf. To create this kind of variation, we use this iteration number. Okay, so every time it goes inside the loop, the iteration is different, and the noise, the resulting noise, is going to be different. How to achieve this? Well, here, as you can see, we have this offset parameter, which is driven by the time. Okay, every axis, x, y, and z axis, is driven by the time. So we don't have keyframes here, it's just time driving the offset of the noise. But the first two, the x and the y axis, have got this line of code. Instead, the z one, which we already analyzed earlier, it just has got this time divided by 2. So let's have a look at this code. Let's open up with Alt-E. We have a time divided by 4 plus something. This something is what the for each loop needs to create diversification, okay, and variation. It's a detail function. A detail function just needs a surface node, an attribute name, and an attribute index. Okay, so we need a surface node. We need to link this to the metadata. It's just a path, okay, to this metadata here. Then we need the attribute. Well, the attribute we need is the iteration, so we put here the iteration. and then the attribute index is 0 this time, okay? So every time we get a different number here. Every time we go inside here, for 40 times we get different number here. And here is the same, okay? Let's move on to another example, which is this static noise I created here. So to recap here, I just called this out leaf, okay? Then I created another noise variation for the Z offset here. Let me show you here in the editor. As you can see here, there's no time involved, okay? It's a static noise, but with this, it's just a static noise with a value of 0.5, okay? But it's multiplied by this iteration, which is the same code we already used here in the noise, in the other noise. It's the same, you can copy and paste it, okay? Then after that, we just rotate this leaf to the right direction, and then we use this time shift. Okay, this time shift, it's a bit more complicated, but just follow me, okay? So, do you remember we had this time offset we created before? It's just an attribute with a value. In this time is 120, but you can change depending on your animation duration. It's just a number multiplied by the curve view attribute, okay? And the result, as you remember, is this. Let me show you the geometry spreadsheet. As you can see here, we have a t off, which is the attribute I created. Let me delete this, which is useless. T off, every point has got a different number, okay? And in my plan, these are going to be frames, okay? So I'm going to have a t minus something, time minus something, to activate the animation of the leaf. So at the first frame, this is 0, so there's no offset. So at the frame 0, the first leaf is going to appear, okay? The second leaf is going to appear at time minus 2. The third one at time minus 5, and so on, until time minus 120, okay? In this way, we're creating an offset in time. How we create this? Well, we've created this one. We're using the curve view attribute, okay? This t off is stored inside this for each loop, so we just need to access it. And to do so, we're going to use a similar code we've just seen here in the noise and in these two noises, but it's a bit different. Let me show you. Because now we're not dealing with a detail attribute, we're going to use a point attribute, because we created here with an attribute wrangle in the points. Every time you create a time shift node, you have this FF, or F at this moment. It's just a representation on the timeline of the value of the frame, okay? At frame 100, we have 100 here. And this is very useful, because this is the time we use to subdivide that offset, okay? So let's go back here, and we use a very similar function, but this time it's not detail, it's the point. So let's see let's see how to write it down. So we use a surface node, which is just a path, and this time we're pointing not to this one, because this is not linked to anything. We're going to point to this one, which is receiving the attribute we need. Then we need to specify the point number. The point number in this case is 0. The attribute we need, which is t off, and then the index, which is 0. Now, since we are looping this 40 times, and every time we use a different t off for every leaf, the result is going to be like this. Let me decrease the quality. All right. So every leaf is going to appear in a different time minus the offset. Okay, and every leaf, now it's not easy to understand with this quality, but every leaf has got a different noise on it. Okay, the displays of the leaf is different for everyone. After that, we just delete some useless attributes like toff, prim num, prim uv, mask, and curve view. We don't need them anymore. We just transform everything with a rotation to put it in a vertical way. Then here I created this attribute wrangle to create this color variation called var. It's an attribute that I'm going to use later on in the shading part, and it's just a random value for this one to create a bit of color variation between the leaves. Alright, so if we continue here to this second root after this part here, oops, sorry, here, we can sweep using a round tube with 16 columns and this radius, and a fall off here, kind of transition for the scale. Then we applied normals, just in case. We smoothed it a bit, and then I deleted some useless attributes, color and mask, which are old attributes, and then I just rotated it. This is the inside stem. There's also an outside stem which is the same, but as you can see, it's a bit thicker. Okay, I'm using these two ones for shading later on, but they are essentially the same. Okay, and then we can move to the last part, which is the hair creation. Okay, this is the result. Let me show you. Okay, so during the plant creation, we have this hair sticking on the stem. All right, let me show you here. Maybe it's a bit. Okay, this is the air applied. Okay, all right. So just one thing here. At the beginning, we choose the x-axis here in the n along curve, and not the curve normal. And this is the reason. Let me show you. As you can see, while this is growing, it's also rotating, creating this kind of issues. So I tried with this x-axis, and the problem is solved. Okay. So for the hair, we just take our stem here, and we need to scatter some points on it and apply the geometry. But what if we just put down a scatter here, for example? We just create some points, and then we use a copy to points like this one to put the air on it. Let's use also this scale. All right. So we just scattered some points, we scaled it, and we copy to points in this geometry we're going to have a look at in a moment. And let's see what happens. As you can see, the points are moving. Okay. So let me show you here because it's easier to see. The points are not sticking in the geometry, they are constantly moving. Okay, so we need to find a better way. So let's get rid of the scatter, this one. Okay, we take our geometry, we time shifted, we froze the creation of the stem at the frame 200. Okay, so when the stem is fully created, we block it. Okay, so as you can see, it's not animated anymore. Then we scatter some points on it, and remember to output these ones. Okay, the prim num attribute and the prim uvw attribute. Okay, so the source prim and the source prim uv. We need them. Why? Because we're going to interpolate these scatter points onto the animated one. Okay, so we're going to stick these points onto this animated mesh. To do so, we take the mesh, we randomize the n, as you can see here. These are the normals, and they are all perfectly aligned to the surface. We just put down an attribute randomize with this n inside the sphere with 3 dimensions. Remember to put in 3 dimensions, okay? And here with an option you can change the global seed if you want. So now we are going to interpolate the scatter points onto the animated geometry, and this is the result. As you can see, the points are not moving anymore because we're using the source prim and source prim UV attributes to stick the scatter points onto the polygons, okay? Then we have this p-scale attribute wrangle. It's just a fit function using a random number and fitting it between this minimum and this maximum, these two, okay? Here is the geometry I created for the hair. It's just a simple line with 5 points, okay? I use the point VOP with an anti-aliased noise. We already discussed this before to create this kind of small noise here. Then I resampled it to create just a bit more points. Then I swept it with just 5 columns and as a round tube and a radius of 0.02. Then I apply the normals and then I sticked it, okay? As you can see, this is the result. You can here increase the scale, but I think this is good. Alright, so now we are at the end of this course. We are going to have a look at the shading and rendering part. Alright, let me show you my lighting setup. As you can see here, we just have 3 lights. Now I can deactivate them so you can better see what's going on. We have this vertical aspect ratio for the camera because this was intended for Instagram Reels. So here is the camera and here are 3 lights. There's a light dome, which is just an HDR, and as you can see it's very subtle with a bit of variation in the tint. Then we have our key light, which is just a point light here, up here, with a bit of tweakings in the shadow and a bit of contribution scale, which is affecting the volumetric scattering. If I put this down to 0, we lose this kind of atmosphere with these light rays over here. So I really liked it. And then to create the translucent effect on the leaves, I just put this a backlight, which is just a spotlight. As you can see, we have a bit of light transpassing the leaves. Here you can see the tweaks in the spot and in the shadow. There's no contribution from this light. Okay, so let's continue to the shading part. As you can see here, we have 4 nodes, 4 geonodes. They are just pointing with an object merge. They are just pointing to their output in the fern setup here, which is the whole setup we have already learned. So we have the leaves, the inside stem, the outside stem, and the air here. Another important thing is that I'm working in ACES. As you can see here, these are my default settings. And also in Houdini, the software is loading with this OCIO configuration, since I'm working with ACES. If you are using ACES colored space, you have to remember to convert all your RGB images in ACES. And to do so, I use this simple, and I think this is a free software called Pico Color Space Converter. It's very straightforward. You just take your image and import into the software. You select it, then you specify the color space. In this case, this is a text or sRGB. You applied it to the selection, then you tweak here the settings, and then you choose the output color space. In this case, it's an ACES CG. And then you click convert. About the textures, well, I just took a screenshot from Houdini. I don't think this is the best way to do this kind of stuff, but it was fast. And so I just imported this image in Affinity Photo. And then I applied some photos I had of some horrible photos of my Boston fern leaves. Here they are. And then at the end I came up with this diffuse texture here and this fake bump texture here. Then I used also another variation, which is a low quality, but never mind. And then as you can see here, there are the ACES CG EXR conversions. Let's have a look at the Redshift materials. Let's start from the leaves. It's just a basic material, and I just played with the diffuse, translucent and reflection inputs here and a bit of bump map. How did I achieve this? Well, I just imported two textures here, the number 2 and the number 3, EXR ACES version of them. Then I color correct the number 3 and I put them inside its color mix to mix them using a mix amount. And as a mix amount, I use that color variation attribute called colvar. I created in the fern setup here. If you remember, I created this wrangle with this color var based on the random ptnum. And now I can show you the result of that attribute after a bit of RAM tweaking. Here is the result. Let me show you. We have this kind of a gradient image, and we can use it to mix the two kind of leaves. So after this tweak, I just output this mix to these 4 different color correction nodes. The first one is going inside this second color mix with another color correction, okay, from the same image. So I did this kind of hue variation, very subtle hue and saturation variation. I plugged in the color mix, and then I used this mix amount using the same color var attribute up here, and then I plugged it in the diffuse input. Then I took another color correction here and I plugged it in the translucent color, and the weight is this 0.7. all right, you can just play here and see what's the best result for you. Then I took another color correction. I put the saturation to 0 to achieve this kind of fake specular map, and I plugged it in the reflection wave with a roughness of 0.4. all right, nothing else here. Well, I just tried here to play, but in the end I didn't use it. So the last thing is that I used the two textures, two bump textures. I mixed them the same way I mixed this one here and plugged them in the bump map node with this height scale value. Alright, so this is about the leaves. Let's have a look at the stem. The stem is very easy, it's just a color, okay, a green color, plugged here in the diffuse color, and then I used this kind of sandy green for the translucent color with this wave 0.2 and a bit of bump created by this maximum noise wavy turbulence. Remember to take here the UV vertex, otherwise the noise is moving on the geometry. That's not what we want. Here is the bump map value, and here it is. So about the hair it's very straightforward, just two kind of green here with very low saturation for the diffuse and for the translucency, a bit of reflection with some roughness and nothing more, or yeah, a bit of transmission here, 0.2 as a thin wall. And for the stem inside, which is the stem inside the green one, which gives a bit of brown idea here in some points. It's just brown color with a green translucency. Nothing special. Alright, so this is the result. And the last thing is about the rendering. A couple of notes here for the settings. I use this minimum and maximum samples with this error threshold. For the global illumination I use this brute force with a 32 brute force GI rays. And remember to take this volumetric scattering enable thick, otherwise you don't get the rays because you're not dealing with volumetrics. And the last thing, if you have RTX cards, you can take this and it renders faster. And bucket size of 512. I also tweaked a bit the photographic exposure here, as you can see with these values. It's just a small tweak. So this is the end of my tutorial. I really hope you enjoyed it. Yeah, I know maybe it's a bit too long, sometimes it's a bit boring, but this is my first try, so sorry for that. If you have any suggestions or questions, please leave them in the comments below. Thank you so much.